this first section here is titled threat modeling. All right, so what does that really mean? Well, when we talk about threat modeling, this is sort of the beginnings here, right? We've either got an existing web application or we're building a new one. And sort of one of the first steps is to think about, okay, what are the threats and mitigations involved with sort of this thing that we want to protect? So typically what it involves, if we break this down into more detail, is we start off talking about what is it that we're worried about at first bullet, right? It's kind of a good place to start, which is, this is the way I like to think about it, right? I'm building a new application that's going to expose some data. Okay. Now, if I think about it from the point of view of like the director of the organization, what would be the things that would, keep him up at night, or, make me lose my job, or what are kind of like the worst case scenarios, right? What are the things we're really worried about? So the answer might be, oh, we don't want our users' social security numbers to be exposed, or we don't want the ability for somebody who's not allowed to be able to create a new work order, or to basically have a list of kind of, these are all really bad things, right? So you kind of create this list. And you have no idea about if any of that would even be possible or whatever, but everybody agrees they're bad. So then the second step, list of assumptions that can be checked or challenged in the future as the threat landscape changes. So as the application evolves, so now it's being used by even more users. It used to be an intranet application, now it's an internet application, right? So the list of assumptions here, these are things that should be true. So for example, work orders can only be created by people who are authenticated or in the role admin. Social security numbers should only be visible by the owner of the number or somebody else or whatever. And so if you can sort of have this list of things that should always be true, okay, and then it's starting to walk you down the path of being able to create like a test plan, right? Think tests you can run, exercises you can do to sort of validate that everything's still okay. Okay, we talk about things like unit testing. It's good to have a security oriented set of tests, which are things that we can check anytime we want, right, to feel like our system's in a pretty good place, right? So we've got a list of things that would be bad. We've got a list of things that we know should always be true, some invariants. And so now we have some tests that we can perform, some actions that we can take to help validate that those things are still true, right? Because something just changed. We just opened this up to more users. So are all of our assumptions still, true? Can we validate those, check those? List of potential threats to the system. So that can vary what that looks like, but if you're exposing an application to the web and you think about potential threats, you might think, well, we want to make sure that we're in a good place when it comes to sort of those automated bots and things that are out there running, trying things. We've seen those before, those are in our logs. List of actions to be taken for each threat. Now, one thing I want to mention about this bullet here, it's not just about, okay, what things should I do to improve my application? So after these 2 days, if you're responsible for a particular web application, you may see some things today and tomorrow where you think, I should go into our application and I should add that and I should implement that and I should improve that over there. Yeah, sure, you should have some, some things in your mind of ways to improve your app. However, another thing you should have is there should be a list somewhere, right? So that you know what actions should be taken when it goes bad, right? Because you're gonna do the best you can to create a secure web application and protect your data and protect your infrastructure and everything else, but sometimes there's nothing you can do, something's gonna happen. So when that thing does happen, what are we worried about up at the top there? What does it look like? What does the process look like? What's the flow? Somebody may have already defined that, but there should be something in place, a series of actions that should happen. Once you discover that some sort of breach has occurred or some sort of vulnerability has been exercised, everybody should have in their mind a reasonable idea of like how things proceed from there, okay? Sometimes there's legal or regulatory requirements involved, like you have to notify your users within X number of days of their personal information being sort of revealed. Other things could just be internal in your own policies, but yeah, something should be placed. How to deal with it when it does go bad, right? And we mentioned sort of a way of sort of validating and checking verification. So we'll talk more a little more about that. Okay, so And you can read entire books about threat modeling. That's sort of the general idea. It's a good place to start, just to have a good context about, okay, yes, this is a web application. Yes, we want to make it secure, but what are the things that, if they did happen, would be really bad? What things have we put in place to make sure those things don't happen? What have we put in place to check to see that, yes, we can validate that those things are not possible, at least to the best of our ability? And what should we do if one of those bad things actually did end up happening despite our best efforts, right? Sort of a good first step. Now, kind of associated with modeling, threat modeling, is this idea of profiling. I mentioned that it's useful sometimes to think about this problem from the other side. So imagine for a moment you're the bad guy, right? Or let's say I'm the bad guy, okay? I'm the bad guy and I've decided that you're my target for whatever reason, okay? So now what is that process going to look like? If I'm doing it sort of for real, or if I'm doing it as part of a penetration testing exercise or whatever it happens to be. So the way that process is going to go is step one is I'm going to start doing what's called profiling of the target. So for whatever reason, I've decided you're my target. Great. Now I'm going to start profiling you. Okay. So what does that mean? Well, gathering information about the target. And this falls into different categories. So we have like organizational profiling, infrastructure profiling, application profiling. And so let's talk about these a little bit. So the first step, organizational profiling. This is where I just want to learn as much as I can about my target as an organization. So where are you located, like physically in the real world? What are some people that work there? What are their names? What are their phone numbers? What are their email addresses? Do the employees work 24 hours a day, or are there specific times when there's usually nobody there? Upcoming events. Can be an interesting one. If you're my target, and I know that there's a particular conference that a lot of the development team goes to every year, that's an interesting time of the year for me, because if I know that most everybody is away at that conference, that may be a good time for a social engineering attack, where I place a phone call to the receptionist and say, hey, this is so-and-so from, IT. I forgot to do blah, 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 and then some way, figure out a way that she gives me her password or something. Because the softer target when everybody's away at the conference, right? A lot of times the best place to start for this is like on, the about page or the contact page of the website. So, and we'll get to sort of why you care about this and what you should do about it in a minute, but this is my target, so I just start, poking around. And just, again, I don't know what I'm going to do with any of this information at this point, but what I'm doing is just assembling, again, names, emails, phone numbers, all these different things. Trying to get a better picture of the organization, and how I'm going to use that information, it might come up later. But step one is just to sort of put all that together, kind of like create a binder of information. In the 4-day class, sometimes we take this a little bit further, and I pick a website out there on the web, and within 10-15 minutes, we know who the president of the company is, where he lives, where his children go to school, what bus route they're on. I mean, it's the modern world, it's easy to get there, right? How you use that information, not worried about that yet. Just trying to assemble, just taking it all in, right? The more I can learn about my target, the better. All right, so, because really, a lot of times the most effective security vulnerabilities are the simple ones, right? To convince somebody to give you the password or let you in the door. Versus trying to do something really technical and complicated. If you talk to any sort of security expert at a large organization and ask them, what is the one security issue that sort of is the hardest for you to deal with and, just gives you the most headaches and struggle? And they're not going to say, oh, buffer underflows on the server or whatever else. They're going to be like, no, people following other people through the door at lunchtime. Because that's what it is most of the time, right? So if I can walk into your building and plug something into the network, that's a good first step. So basically what I'm trying to get at here is it's a team effort, right? No matter how much time you spend learning about how to prevent cross-site scripting and cross-site request forgery and injection and all these things, if everybody's not sort of got their mind in the game here, something very, very simple can sort of just destroy the whole thing, right? When we're talking about security as sort of a big picture, okay? Weakest link, right? So I just like to just take a few seconds just to kind of mention things like that because personnel in your organization, everybody, right, should have some level of security awareness. So no matter what you do, there's no substitute for making sure that your people have strong passwords and don't send sensitive information through insecure means. You could have encryption in your database and you can do all sorts of crazy stuff. But if you've got some employee who just copies the data from the social security number or whatever and sends it via unencrypted email, right? So, and then like I said, physical security. Firewall doesn't do you any good if I can walk in and plug in on the other side of it. Cool. Good enough. Now, when it comes to this organizational profiling business, really the takeaway is that top bullet, which says that you should be aware of what information about your organization is publicly available or easy to obtain. That doesn't mean you change anything, okay? Because there's a whole lot of information that you have to make publicly available. This is the way it is, okay? But you should at least kind of be aware of what's out there, okay? And that can be helpful. So, just be the bad guy for a day, surf around, see what you can discover and figure out, right? So, and we'll take that a little bit further, but that's important. So the next step, once I've sort of, and I get to decide how much time I spend doing this, right? I may spend, depending on the target, I could spend an hour, a day, or 3 months, right? Assembling all this information about my potential target, okay? I mean, in some cases, it even comes to, I haven't done it personally, but, digging through dumpsters and all that kind of stuff that you, read about and whatever. Infrastructure profiling. So now we go a little bit further down the stack here. So now this is us gathering information about the technology infrastructure that supports the application I'm interested in. So this is where I want to know, okay, where are your servers hosted? What operating systems are they running? What web server versions? What frameworks? This kinds of stuff. So who owns or is responsible for the domain name? Because if I can just hijack your entire domain, well, that gives me all sorts of cool opportunities. Is the web server located at a physical location controlled by the target, or is it hosted by another party? That's something that's interesting to know, because if I'm going to attempt to compromise your web application and I'm able to succeed and I can sort of get access onto that machine, what does that open up for me? It's very different if I'm now on a machine that's on your internal network versus I'm just on some machine that's out there in the cloud somewhere where I can't really do much, right? And sometimes it's not immediately obvious, but it's not all that difficult to figure out. So for example, let me come over here and I'm going to open up a tool. So I'm going to take Wireshark here, which is a protocol analyzer, and let's pick a target. So how about our friends over at the NSA? So I make a visit to nsa.gov, and so now I'm kind of interested to see a little bit more about what's going on. Now, if I just use the browser developer tools, I can only get so much information. So I see the request that's being made to some server. I see the headers that are coming back. And I see this request is being made to 23.63.48.135 port 443. Yeah, I want to know a little more than that. So because I had this guy running when I made this request, what we'll do is we'll come over here, and what I'll see is here is the DNS query that's made to resolve nsa.gov into a machine that I can talk to. So here's my request to resolve nsa.gov. Here's the response to that query. Actually, let me see. Standard query, here's the response. So here's the answers. So I can see that nsa.gov is a CNAME that actually resolved to nsa.gov.edgekey.net. nsa.gov.edgekey.net actually resolved to e16248.dscb.akamaiedge.net, and that resolved to 2363.48.135. So basically what I found here is, well, bummer, because this web server is not actually like in a room in Fort Meade, Maryland, it's just some machine sitting on Akamai's network. It's a content delivery network server. So not gonna be so exciting if I actually, manage to get in here. It might still be cool because I can still maybe modify the homepage of the NSA, which would be really cool, but get some cred for that. But yeah, so these are the kinds of things that you may be looking for. Now, I'll get to kind of where the payoff here is on this, but so that's one of the things I'm interested. What OS and web server software is involved? Are there any intermediaries between the client and the web server? Typically not difficult to find these guys. A lot of times you can determine that just by looking at the kinds of things that are included in the headers and the responses that are coming back, or based on sort of patterns that you can discover when you're making multiple requests. Date times may not be completely synchronized up, other things, and so you can usually kind of discover these sorts of things. Now, we're going to do this live for some other targets here in a second, but footprinting. So footprinting is kind of part of infrastructure profiling, and this is just figuring out sort of what kind of footprint your organization leaves on the web. So the scope of the target application organization, one kind of way to do this is something like who.is. And so what I'm going to do is I'm going to pick a target. So let's say there's a partner organization we work with called Webucator. So they also provide sort of instructor-led online training and stuff. And so they give some business to us, we give business to them, whatever. So they're like a partner organization. And so if I was to take them and plug it into here, let's see what other kind of things we could discover. Well, first thing is we see that their the registrar info is GoDaddy, so that's who's sort of their domain name registrar. So if I could potentially get into their GoDaddy dashboard or something, I could maybe hijack the domain or do some other cool stuff. Name servers, ns493.awsdns61.com. Ooh. So they use Amazon Web Services as their DNS provider, which probably means I bet they're using AWS to host their web servers too, but we can confirm that in a minute. There may be some information in here too that may be of interest, I don't know, but let's go DNS records. So under DNS records, there's our name servers, but then also notice here for their mail exchange records, googlemail.com, so they're using Gmail as their business email provider. That could become useful. Then we also see there's the IP of the web server, which we can get in a variety of different ways, but let me just for fun pop that into there. And then give that a few seconds. But basically the takeaway from this is I just want you to get the idea that it doesn't take a whole lot of time. I mean, I'm only spending 10, 15 minutes here, but if I was to spend 2, 3, 4, 5 days doing this full time, you could have a pretty good picture and understanding of the target that you're about to sort of look at. Now in this case, if I look in the trace route down here, I see something interesting, which is here. And so yes, they are hosting on AWS. So EC2 is AWS's instance sort of hosting framework. And that's actually the EC2 internal IP 10.0.0.1.4, which is not all that useful to me at the moment. However, if I'm able to find some other machine that's also on AWS that they host, maybe it's one they don't pay as much attention to, like their Redis server or something else, and I'm able to sort of penetrate that, well, now I'm going to be on the local subnet where the web server sits, and I know that 10.0.0.1.4 is the machine that I can jump over to. So I'll record that, write it down, whatever, that come in useful later. And so you sort of get the idea, right? Scanning, so because I've got the IP address of the web server there, another thing I might do, which I'm not going to do here, is basically look at that machine to find out if there's any other interesting ports that are open. 80 and 443 are probably there, sure, but I'm looking for administrative access points. So how do you get content onto your server? Do you use FTP? Do you use IS management service and do like web deploy? Hey, do you have like a remote desktop open on that thing? These are things I'm looking for. And these are all things we're not going to really talk about at all, but the bottom line, the takeaway from this is this last bullet, right? you as a web application developer or administrator or whatever your role is, should assume that anything that is accessible from outside will be found, okay? Do not practice security by obscurity, right? Oh yeah, we want to use FTP, but we won't run it on port 21. We'll run it on some weird non-standard port so people won't find it. Okay, just assume it will be found, okay? Your goal here, like when I'm putting together a web application that I'm going to expose to the internet, I should feel totally comfortable basically putting all the information about that web application just out there on the web. You want to know all the ports that I have open? You want to know all the IP addresses and DNS names and everything? Sure, you can have it all. It's not going to help you, right? That's where you want to be, because that's stuff that's not that hard to find anyway. All right. So here's a quick example of this. Banner grabbing, okay? Commonly misunderstood sort of thing here. So banner grabbing is the making a request to a web server and looking at the response that comes back, specifically looking at the headers, and seeing if the web server returns as one of the headers the server header that includes information about what web server software this particular machine is running. Okay. Now, do you think it is a security issue or problem to be returning that information from your server? Some people say yes. There are some tools that you can run that are out there. Some are web-based, some are not web-based, and it'll generate a report that says, here are some things you should do. And sometimes it lists this as one of the things you can change. Okay, well, you know what? I don't really have a problem with them recommending that you change this or remove it. But you know what? I also really don't have a problem with it being there. Okay, and I'll tell you why. But for all of my web applications, I just leave it alone, right? Fine. Yeah, you want to return the web server? Go ahead. That's big whoop, right? And I'll get into more about the why, okay? But first of all, why is this used? So whenever I see something like this, and I think I may want to remove it or change it, one of the questions I should ask is, well, am I going to break something or screw something up if I mess with this? The server header is typically never used by clients. So the browser will not do something different depending on what comes back from the server, right? You may have a server that produces different HTML based on who the client is, Internet Explorer versus Chrome or something, but typically clients don't do anything different based on what the server is. The only thing this is really used for is there are sites that are out there that you can go to that will give you like statistics and say, 75% of sites use IIS and 32% of sites use Apache or whatever, some stuff like that, yeah? And the way they gather that information is by making requests to all sorts of different servers, seeing what comes back, and then that's how they assemble those metrics and things, right? So could you safely remove it? Sure. Could you modify it? Sure. Why do I typically not mess with it? Because the thing about the server header is if you do return it, then I can see what you're running. But if you don't return it, it's still super easy to figure out what you're running, okay? There's a process called fingerprinting, which is basically we look at the behavior of the web server to determine what server software you're running, right? We can usually figure out the make, the model, the version, as much as you want to know, okay? And the reason why this works is because the HTTP protocol has certain things that are very well defined on how web servers are supposed to behave. But there are other things that are actually not defined by the spec. And what that means is different web servers will behave differently. So let's say, for example, I send a request to some web server and it's not expecting that kind of request. So I send a put request to a web server, okay, that's not expecting to receive a put request. Well, Apache will return a 405, IIS-5 will return a 403, IIS-6 returns a 411. So they all behave a little bit differently in that sort of unusual circumstance. The other thing is the headers themselves. The names of the headers are very well defined. However, something like case is not required to be a certain way. So some web servers will return content type and the T will be uppercase. Other web servers, the T will be lowercase because it can be either, so web servers differ. The order of the headers. So the date header, for example, in Apache, the date header is listed before the server header, where an IIS is listed after the server header. Okay? So there's a whole bunch of these like behaviors and rules that you can look at, and these are not easy to change, that can tell you sort of what web server type you're running. And of course, if there's a set list of behaviors that you can look at, I bet somebody's built an automated way to do it. And absolutely, there's a bunch of them. Some of them are web-based, some of them are desktop apps. A well-known one that's been around forever is one called HTTPrint. And what you can do here is just open up this app, point it at a server, and then it'll tell you, like, for example, oh yeah, this guy's running Apache 1.3.27, and I'm 84.34% sure. And you can look at maybe here's why, and it'll give you a list of everything else, right? So in other words, anybody that I'm really worried about is going to know how to identify what server I'm running. It's like, 101. So I don't. And the other thing is, it's kind of funny, but I mentioned this to the group this morning. I thought about this a little bit, and the fact that you can change this to whatever you like. So even though you're running IIS, you could return a server header and have it be Apache, or at least say Apache. Or you could say server and put like none of your business here, okay? But if I'm somebody who's kind of just browsing around looking for an interesting target, and I see that your server is returning none of your business as the server header, I'm kind of like, oh, that's interesting, right? Or if I find out that you're returning Apache when you're actually running IIS, then I might be like, oh, okay, being cute, huh? All right, let's see what we can do here, okay? So you might not want to like, you just want to be vanilla and kind of just fade into the noise, right? You don't want to do something that stands out that an attacker may pique their interest, right? Yeah, so just for fun here, let's let me pop over here and let's go over here and take a look at what headers are coming back. So let's see what we got. So here's our response headers. So content type gzip, date, server is Microsoft IIS 8.5, and then there's an X powered by ASP.NET header here. Okay. Now, the interesting thing about IIS is IIS kind of goes in pairs with Windows versions. So Windows Server 2003 was IIS 6, 2008 is 7, 2008 R2 is 7.5, 2012 is 8, 2012 R2 is 8.5, and 2016 is 16. So if I see that you're running IIS 8.5, I now also know that you're running Windows Server 2012 R2. But again, even if you weren't returning that information, give me 30 seconds, I'll tell you what it is, okay? So up to you though, but if you want to change it, that's totally fine. Obviously you're never going to make it less secure by removing it or changing it. One thing I also want to show, by the way, while I'm here, this extra header, this X powered by ASP.NET, when you install ASP.NET on an IIS machine, by default, what happens is there's this response headers module here, and you can see this X powered by ASP.NET is here. And so that'll get added to every request that goes out of the server. I can click on it and just remove it. I added this other one here for another demo, this XMy stuff, whatever. So if you want to remove that, you can feel free to remove that. I did notice with this one, by the way, if we go somewhere else, let's go over here and look at the headers here. And you can see we've got even a little more information this time. So server IIS 8.5, ASP, powered by ASP, and X ASP.NET version 4030319. I'm a little bit less excited about that one being there. Main reason being, it's not as easy for me to figure out the specific sort of minor version number of the framework you're running. So the fact that you're giving that up, I'm not as excited about. Not a huge deal, but it kind of depends on how old it is that you're running, right? So for example, 4030319, if I was to grab this and then jump over here and go to like CVE details and do some poking around. So this is the idea, is once I know sort of the specific version number of the framework that you're using, now all I can do is go look at specific security vulnerabilities related to that version, and now this gives me a list I can start working through to try certain things against your application, right? But again, for you and your applications, you can do the same exercise, right? So you can say, well, here's the version we're running, so let's see what's out there vulnerability-wise, and you may go down through some of the stuff in the list and think, no, this is not really a concern for us, or we're good in those instances, or you may find something that needs some attention. Something that can sort of affect the results if I'm doing this type of profiling is intermediaries. So it's possible that you've got load balancers or proxies, firewalls, IPSs, things like that. But again, like I mentioned earlier, this does get a little bit more involved, but typically just by looking at the traffic, looking at the responses that come back, and then being sort of smart about how we send the requests, we can usually discover all these things and figure out what's there, and versions and everything else. So again, bottom line, just assume everything will be discovered, right? I know what reverse proxy setup you have. I know what firewalls you're using. I know, because, but that's okay. I don't care if everybody knows that. That should be fine, right? Okay, so now we start getting a little more interesting. All right, so now I've done some organizational profiling. I've done some infrastructure profiling. Now we go to the next step, which is now I want to learn about the internals of your application. So how is your application actually put together? How does it function, right? What frameworks are you using, languages, things like that? And so I'm looking at things like the flow of the application, how the components fit together. I'm really trying to learn about how your application works so that later I can start identifying weak points and vulnerabilities. So I'm looking for things like the directory structure and sort of what pieces make up your application. I'm looking for file extensions. So when I look up in the URL and I see certain file extensions up there, that can tell me something about like what you're using and things a lot of times. Source code, comments. So I look in the comments in your HTML source, and sometimes I see stuff that really shouldn't be in there. Comments are good, okay? I love comments, but they don't really belong in a production environment and that we're going to deliver to end users. They don't need those comments. Plus, you're just using up bytes on the wire anyway. So maybe at the very least, just make sure you're looking at what comments are actually going down to the client, and think about if that's okay. Or maybe part of your build pipeline is you strip some of those out or remove them. Query string values, cookies, hidden form fields. This is me just trying to understand and find the interesting aspects to your application, right? So again, let's just some examples. I'm looking for things that does like user identification, because what happens if I modify that? What kind of results do I get? Session identification, database queries. Like for example, if you're doing a search based on some sort of value, that's an injection point. I'll try to do stuff. Encoded or encrypted values, things that are being put into hidden form fields or cookies. A lot of times those can be interesting. Boolean arguments. I have seen web applications that do things like this, right? Admin equals false. Oh, you change it to true, and all of a sudden you get more stuff. No matter how bad stuff that you discover in your applications that you find, believe me, I've seen worse. Okay, I had a client one time, and their web application was triggering some functionality that was like saving some file to some remote location or some other thing, and I was like, I don't understand how that works. How can that code have the sufficient permissions to be able to make that work? Why does that work? And they looked at me and they said, oh, well, we've set up our security permissions in such a way that we've eliminated any sort of permission issues to make sure we don't have issues related to permissions. What? I don't understand what you're telling me. What have you done? And he said, well, we just run everything as admin here. Everybody's an administrator. All applications run as admin, and we just use the SQL Server SA account for everything. That ensures that everything always works and we never have any sort of permission-related problems. All right, cool. All their IIS application pools were assigned to admin. I was like, that's beautiful. Now, that can actually be a very valuable debugging technique, right? Because your application doesn't work properly. So you elevate it to run as admin, then it works, then you put it back the way it was and it doesn't work. Well, now you've narrowed down the problem. You know it's related to some sort of permission issue, but it's that you change it back part that you want to make sure not forget, right? Anyway, so yeah, I've seen stuff like that. Okay, so let's poke around a little bit more over here just for funsies. So this is our page here. So let's do a view source and see if anything pops out. So at first, nothing too exciting. Your CSS and script includes below. Okay, that's good. Inline styles and stuff. Okay. Oh, view state. Oh, wonderful view state. So because I have view state in here, that's ASP.NET Web Forms. It's an artifact of that particular technology. So now I know you're using web forms. Because view state is just encoded, I could take that out and plug it into a page somewhere, and it'll tell me what's in view state, which is probably not all that interesting. It's just the sort of the previous state of the controls. But it's possible that you can add stuff into view state programmatically, so I might check for that. There's some JavaScript and stuff. Okay. Some other links to other things that I may dive into later. Financial portal.aspx. That's just another giveaway about the technologies. Go down more. I'll see other things in here. Like I think I saw some CFMs and stuff in here as well. Cold Fusion. And sometimes you may actually learn a little bit about the developers and kind of their style and other things to look for. Yeah. Another thing we could do is let's take our domain here and make a request for robots.txt. Robots.txt is a file that's typically put on a web server to tell search engines where not to go, because there's certain places you don't want indexed by search engines. However, places where you don't want search engines to go usually are more interesting places that I may want to go. So see Telerik in here. So popular, UI component library people use, especially in web forms and stuff. Our search results CFM, so our Cold Fusion kind of thing. Something test script, stuff that I'm not sure how interesting it is, but again, this is kind of part of the profiling process. Is just looking for places that may be of interest to me. Or like, for example, in the case of our partner there with Webucator, theirs is even more fun because they've got stuff in here like Open Sesame or Punch-Out or Partners Extranet. Again, this goes back to what we said earlier, which is don't assume stuff won't be found, because there's all sorts of different ways and varieties to find things. Even if it's not listed in robots.txt, temp is interesting a lot, test is interesting. You can use programs that'll do dictionary-based attacks for iterating through directories that are present on the web server, other things like that. So lots of choices and options. And like I said, at this point, when I'm doing this sort of this profiling step, I'm not so concerned with you knowing who I am. In other words, I don't care that you can see I'm doing this. It's going to all show up in your web server logs, but for the most part, I just look like a regular user just surfing around your site. However, if you look in your web server logs, sometimes you can see a series of requests, and when you look at it, you go, that looks like somebody's profiling my application, because they wouldn't make requests like that unless they're trying to figure out how my application works. And so that can be interesting just to spot that sort of behavior. You don't necessarily do anything about it, but it's kind of nice to know if that kind of stuff is happening, right? Now, once I get to the point, now notice during this profiling stage though, you usually won't see a request for robot.txt and a request for some of those other resources immediately followed by like exploit attempts, okay? Because if somebody who's doing this for real and they know what they're doing, they're going to do their profiling, they're going to identify these different areas of the application, but they're not going to actually attempt to do anything evil at this point, okay? Because all they're doing is just profiling, assembling a picture of how the application works, how it's put together, and then they kind of step aside, and then they sort of formulate a plan. They think about, okay, I've identified 5 or 6 different areas that look interesting. Let's prioritize these of like how interesting they are in order. And then I come up with an idea of, okay, here's one particular exploit I'm going to try. And then when they go to do that, they'll typically do something to make themselves more anonymous. So they'll use the Tor network or other things to kind of, because now they're actually going to start taking actions that are potentially can raise some attention. So, you know, I'll be more careful. Okay. All right. So what about on your side though? Countermeasures. What are some basic things that you should be doing or might want to start doing when it comes to profiling? Well, I already said that you should be aware of what information you're making available. Awareness is important, but also don't make it too easy, right? Number one, do not allow for directory browsing. You may have come across this sort of behavior before where you go to some web server somewhere and you make a request for a directory and there's no default page assigned, so you just get a list of the files and directories that are there. We don't want that to ever happen. It's a bad user experience for one, but two, that's just giving away information, making it too easy. So in IIS, there is a directory browsing module here, which you can either enable, disable, or what I would recommend you do is just uninstall this module completely, so it's not even there, because it's probably not something you're ever going to actually want anyway, especially for your public-facing sites. Use different web document routes for user and administrative interfaces. Well, basically separate them as much as you can, right? If I'm looking at something like a web server in IIS here, and I have different applications, what I may end up having is I have an application that's got, say, I don't know, 100 different pages. 98 of those pages is just presenting information, no big deal. But 2 of those pages are sort of special. They allow for, like, you know, creating new records or for deleting things or whatever, or for uploading files. And so those 2 files, those 2 pages require some special elevated permissions, right? So here's what I don't want to do. I do not want to elevate the privileges of this entire application just so I can accommodate the needs of those 2 pages. Instead, what I really like to do is separate that functionality off into its own separate application so that these 98 pages can still follow this idea of least privilege, which we'll talk about in a second, and just have very basic whatever they need. And then these 2 can have what they need, which is their elevated privileges to do their task, right? But they have these separated into separate applications so I can kind of monitor and control them separately, right, as much as possible. So I prefer something like admin dot versus mysite.com/admin, where it's just some pages in a subdirectory. You can still separate those out into a different application, but as much as I can, I like those to be their own little worlds, right? So I can control them better. Place the web server content root directory on a different volume from the system root. Okay, so in the case of our IIS web server, this would be our, you know, www root directory. Okay, I really, really do not like having www root on the C drive. Okay, a few reasons for that. One of them is if somebody's able to sort of get a foothold into my server, I don't want them on the system drive. The other thing is because that's your content of your website, that content can potentially grow, especially if you've got an ability for people to add new pages and things like that. And so the size of that directory is, you know, kind of variable. And if somebody's able to, again, get a hold into the system so that they can add additional content into that directory, I don't want them to have the ability to potentially fill up that drive. Because I don't know if anybody's ever seen what happens, but if you've got a Windows server and the C drive ends up getting to where it has like no available space on it, bad things start to happen, okay? Sometimes you can't even log into the machine at all, okay? So I really want that, at the very least, on a different volume on the same machine, or if possible, to even have your web content on a, you know, network attached storage or something off the machine completely. That has performance implications, but at the very least, I don't like it on the C drive, okay? Strip developer comments on production server, we mentioned before already, kind of. Disable detailed error messages for remote requests. So when something bad happens and an error is thrown, I want to record that information so I have something I can look at to go back and figure out what happened, but I do not want to reveal information to my end users. They don't need to know that stuff, right? If I can't reach the database, just tell the user, sorry, can't reach the database, try again tomorrow, or call this phone number. They don't need to know the names of the tables and columns and all that stuff because that falls under the OWASP item of sensitive data exposure. If I'm exposing internal information about my system, like column names and table names, that stuff can then be used against us for, you know, follow-on attacks and things. And so I'll make sure that's not happening. Be aware of those things you cannot avoid making visible and assume they are known. Kind of already said that. When it comes to this detailed error messages thing, I do have a quick example here that I shared with the folks this morning. So there's a website out there called Oil and Gas International. It's oilandgasinternational.com. And most people had never heard of this site. I'd never heard of this site. And then a while back, something happened. And after it happened, everybody who's in sort of the security kind of training area was like, oh my gosh, this site is not going to be talked about in every security class from this point forward forever. So what happened? Well, Oil and Gas International is, I don't know, some site out there that provides news about the oil and gas industry. And you can subscribe, and it's not cheap either. It's like $439 a year to subscribe. So, okay, to get news about oil and gas and stuff, okay. Okay, so Oil and Gas International was not running over HTTPS, okay? But they had a login form and everything else, but they were not HTTPS. So Firefox released a new version of their browser. And what they did is they put some things in place so that if you're typing something into a password box and you're not on HTTPS, Firefox pops up this little box here that says, this connection is not secure. Logins entered here could be compromised. Learn more, right? To kind of make the user aware. Well, the person who's responsible for the Oil and Gas International website saw this and didn't like it. So what they decided to do was they went to the Mozilla Bug Tracker, which is where you can report like bugs and things about Firefox, and submitted this bug report. So basically, the bug report that he submitted was something along the lines of, your message that's popping up is sort of is making our users concerned. We have our own security mechanisms in place, and we have never had a issue in over 15 years. But your message is upsetting our users, and we did not ask for it to be put there. Please remove this message right away so our users don't see it anymore. What? Okay, so somebody saw, and of course the Mozilla Bug Tracker is a publicly available thing. So somebody opened a thread on Reddit and basically said, hey, look, this guy thinks his stuff is secure. He's never had an issue in like 10 years. So somebody else responded to the Reddit thread and was like, yeah, so I just went to his site, which is HTTP, and I typed some stuff into his login form, and it looks like he's got some sort of SQL injection problem. And so somebody else posted and said, yep, he definitely has a SQL injection problem because I just was able to get all of his records from his user table. Then somebody else posted and said, oh yeah, well, I just dropped his user table. And he followed that up with, oh, and by the way, he should thank me. Because some other user was like, I don't think you should be doing that kind of stuff. And so he responded back and was like, no, he should thank me because he was also storing all of his users' passwords in clear text. So I went ahead and just dropped the entire table before somebody else on this thread could get it all. So he should thank me. Okay. So somebody else on the thread posted and said, well, I just hijacked the entire site now. So when you go there, oilandgasinternational.com, you see my page. And he put some friendly message and, So then, meanwhile, somebody in the thread actually sent the guy an email and said, you might want to go check out this thread because stuff is happening. And at the same time, some other instructor contacted me because he was like, you need to go look at this Reddit thread because stuff's going down. So I went over there and I'm like, oh my gosh, and people kept posting this stuff. And I'm like, oh no. And so why it became a big thing is because it turns out, so there's a little blog article about 5 things we can learn from the Oil and Gas International attack. So the thing that happened, what made this so interesting is because we're going to talk about certain things that you can do wrong, but this guy managed to do like all of them wrong in one site. And it turned into a big public thing. So some of these we've already mentioned. Number 1, your past security performance is no guarantee of the future. So yeah, that was part of his comment. We have our own security system that has not been breached in more than 15 years. Yeah, okay, cool. Number 2, right? Attacks happen. Sometimes they succeed. You need to at least have some way to sort of mitigate the damage. So passwords in clear text, not a good idea. Got because we mentioned that before, that you want to think about, well, if they do get the table, how bad is it, right? So just a bunch of like salted hashes, it wouldn't be anywhere near as bad. The detailed error messages. So don't disclose information about the system. When the person who discovered the SQL injection attack, the very next thing that he did was he basically submitted a request that caused the application to throw an exception. And when it threw the exception, wouldn't you know it, boom, it dumped the entire ASP.NET Stack trace back to the browser. So the user was like, oh, sweet. So I had all the source code there and table names and column names and everything. And so he was like, oh, that makes it easy. And then access control, and of course, number 5 there at the bottom. Yeah, you know. So anyway, you can read more about that one if you want. It's kind of it turned into a thing. But yeah, he kind of asked for it a little bit. So it happens. But he did actually fix on everything. So it's now HTTPS. And so, you know, it's good. All right. So just some really basic kind of countermeasures here. Profiling is going to happen. You shouldn't be upset about it. Let people profile your app as much as they want, but don't, you know, don't make things too easy, and don't set things up in such a way that, you know, if they are able to pull something off, it doesn't cause tremendous amounts of damage. Contain it a little bit, control it a little bit, and we'll talk about logging and auditing a little bit tomorrow as well. Okay, now, a couple other sort of well-known sort of security mantras that you should sort of be aware of. You can write these in big bold text and hang it on your wall in your office or something. So the one here is this idea of reducing attack surface area. Again, it's back to this idea of convenience versus security. Security experts will tell you all the time that convenience and security are always sort of at odds with each other, right? The more convenient you make something for somebody, the less secure it typically becomes, okay? The NSA actually had a list that we would consult at the Pentagon that could sort of rank computer systems based on certain aspects of the system. So, for example, it would be like a level 5 system, a level 4, level 3, level 2, level 1. And so then it would give you instructions on how to make a computer system a level 3 system or a level 2 system, right? So, of course, first thing you want to do is you want to be like, all right, let me look at the most secure, right? Like level 1 or whatever. And so the description of a level 1 system, which is the most secure, the requirements are the system has to be physically secured in a locked room with no network access and no removable media of any kind. It's a pretty secure system. It's not all that useful, but it's a pretty secure system, okay? And so we can't get there, obviously. If we could lock all of our computers in rooms with no network access, yes, that'll be really secure. However, what we can do is try to minimize as much as possible how much surface area we're making available to be attacked, right? And so every time you add a feature to your application, you're kind of making the application more convenient, more useful to your users. But whenever you make it more convenient and more useful to your users, you are adding risk, okay? Because that new feature is now something that potentially, you know, could be exploited, okay? Now, when you're adding these new features and things, sometimes it's code that you're writing, like we mentioned earlier. Other times you're adding some component that was written by somebody else. But you should be keenly aware of, you know, all these things that you've added to your application, and you know, be aware at the very least. You know, keep involved. Like, have they released patches for that? Do I need to upgrade to a newer version? Whatever it happens to be. Also, another thing that comes up is people will typically extend the framework that they're using or the web server they're using to support some new feature. So let's say an IIS here. I have all of the IIS modules installed. I don't need all these modules, okay? I just have them all installed for demonstration purposes. But typically when I set up a new IIS instance, I only install the minimum number of modules that I know that I need, okay? So I want the least number of icons here that I can get, because the less things I have to worry about, the less opportunity for security issues, right? Because think of all these icons as like the attack surface area of my application. Somebody could attack the CGI module, or the default document module, or the compression module. And so the less of these I have, the happier I am. So when I set up a new IIS, I only install the modules that I know that I need. Now, of course, I might miss a few, and so later on something doesn't work, and oh, because I'm missing that module, so I'll go ahead and install it. Something else doesn't work, okay, I'll install that module, and here's the thing though, right? If you install too few modules, you'll know something's missing because it doesn't work. If you install more modules than you need, nothing's ever going to tell you that, okay? So it's harder to figure out which ones can be safely removed. But I want to remove and uninstall the ones I don't need. Now, what happens quite often is somebody will install a module on their web server because they need it, like the classic ASP module. You install that module because you need it, because you have some classic ASP on this particular web server. But then later, that application ends up getting replaced or goes away because it's been replaced by, a more modern MVC application or something. And nobody bothers to go back and remove the classic ASP module. It doesn't need to be there anymore, right? So basically, you've got some attack surface area here that's exposed for no good reason because you're not using it. Now, some people think, well, that's a really simple idea. It's a very simple concept. Just don't install stuff you don't need. But almost every time I do sort of a security review or a code review or whatever, it's always a bullet point that you've got more stuff on here than you need. You need to remove a bunch of this stuff because if the module is not installed, you don't have to install security patches for it because it's not there. It's also not taking up memory because it's not being loaded inside the pipeline of the web server. So there's all sorts of good reasons not to have stuff there that you don't need, okay? All right, so that's what we mentioned here about this web server stuff, okay? So there's a wide variety of functionality that's available, but it's critical that somebody goes through and identifies why each module is there, what purpose each one serves, and which ones can be safely removed, right? Or when you initially set up the server, not to install stuff that's there. Same thing with like additional components or libraries that you add to your application. So when you're in Visual Studio and you add, new NuGet packages or new assemblies, you should have some sort of policy and process in place for the approval and use of third-party libraries. Now, depending on your organization, you decide, how crazy this needs to get. For example, when I was at the Pentagon and I wanted to use some third-party component in one of my applications, oh my gosh, the amount of time it took to get that approved, it probably doesn't even exist anymore at that point. So it was a huge amount of effort, but it doesn't have to be some big, crazy, complicated process. At the very least, there should at least be a list that exists somewhere that says, these are the third-party components we use, and here's the website for each one of these, and here's where you go to find out if there's a new version, and if there's been security things that have been discovered, whatever. So we have somebody that's monitoring and applying updates as needed, okay? And remove dependencies that are no longer in use, right? Yeah, because like I said earlier, sometimes you'll use some component library and then it just stops being maintained, it just kind of dies. You can continue to use it, but sort of at your peril, right? And one last thing here, when we talk about attack surface area, we could also talk in terms of data. So again, this sounds like a really sort of simplistic idea, but how do I reduce the chance that sensitive data will be exposed? Stop storing sensitive data. Really, the only data that you can guarantee will never be exposed is data you don't have. So when I'm working with a customer and they need to implement some sort of like e-commerce functionality into their web application, I highly, highly encourage them to look for a solution where they don't have to store credit card numbers. That's offloaded to somebody else, okay? Because as soon as they start storing credit card numbers, PCI compliance and all these other things come into play and it gets really complicated, and that's data that you don't want to have, right? So sometimes it's unavoidable. You do what you got to do. But I don't give up on this task too early, right? I want to figure out if there's a way. Same with like passwords, right? Users get annoyed sometimes when, they'll call me up and they'll say, hey, I forgot my password. Can you give it to me? No. Well, please? No, you don't understand. I can't give you the password even if I wanted to give you the password because I don't have your password. You created an account, we ended up creating a hash of that password, we store that hash away, and that's what we use when you log into the system to figure out if you've provided the same password again. But I don't actually have your actual password, and there's no way for me to get it. I can reset your password, I can give you a way to change it, but I can't tell you what it is because I don't even know. That's a happy place to be. Now, your user gets a little annoyed because they're like, fine, I'll reset the password. But you know how it is, right? Your user probably uses the same password for your site that they also use for their bank and a whole bunch of other things, and so you don't want any part of that, right? So yeah, so that's something I try not to give up on that one either, right? It's kind of like, oh, we have to make sure that this data is like absolutely secure. Well, do we really need to be having that data? Sometimes the answer is no, and you can save yourself a whole lot of work. Okay. Sometimes it's yes, and then yeah, we're gonna do something. But all right, another sort of security idea here, which sounds simple, but sometimes can be really tricky in practice though, but it's still something that we want to sort of target and shoot for, is this idea of least privilege, principle of least privilege, which means every single component in your application, or you know what, for that matter, every employee in your organization, should only be privileged enough to perform their job, right? Need to know kind of a thing, right? That's a big thing, you know, in the Pentagon and the military is like, yeah, just because you have a certain security clearance doesn't mean you can just go looking at any data you want. You know, need to know. So if I look at my application and I've got certain modules or components in my app, I have to think about what each one of their jobs is and then try to determine if that particular component that has that job only has enough permissions and enough capabilities to do its job and no more, right? Again, we can't achieve perfection here, but that's sort of what we're shooting for, we're aiming for, right? This principle of least privilege. This is another one of those cases where if you have a piece of code that's executing and it does not have enough privileges to do its job, you'll know because it won't work. But if it has more privileges than it needs, you won't know, right? There's no like message or alert or anything that says this thing's got too many permissions, okay? And so you have to think about how you want to approach that when you're building your applications, right? Sometimes the best thing to do is to give it, you know, less permissions than you know that it needs, and then keep cranking it up until you get to the point where the thing works. But, and again, there's a lot of things in play. We talk about IIS. There's Windows disk permissions. There's application pool identity. There's authenticated users. Lots of things that play here. But we want to try the best we can to understand our system sufficiently so we can try to, at least best we can, achieve this idea of least privilege, right? And again, this also helps with sort of mitigation, which is something I'll talk about after the break, which we're going to take our break here in just a minute, which we talk about things like database access, right? We talk about a user comes to our web application, they use our web application, it performs some sort of actions against our database. Well, that's going to involve sort of a layered approach, right, of how we make sure that bad things don't happen, but also even if the worst case scenario happens, we still minimize sort of the damage, okay? And that's where this least privilege is going to come in, okay? So reduce attack surface area, try to develop toward least privilege,